Hi everyone, it's Paul from This Design That. Today we're going to be designing and laser cutting a bracket for a Wi-Fi router like this. Now for these type of functional parts, I would usually either 3D print it or I would probably CNC it from 18mm plywood. This Wi-Fi router is too big for me to be able to 3D print a bracket for it. And because I recently got the Algolaser 22 watt, I thought this would be a good project to try and make something functional on it. And I feel that laser engravers that are 20 watt plus, they start to become functional for me. 5 watt and 10 watt machines that I've tested previously, they can really only feasibly cut at a relatively good speed. 3mm plywood is pretty much all they can do. If you want to start cutting 6mm, 9mm, even 18mm plywood, to make functional parts, you are going to be waiting hours for it to cut. Now, I recently got some birch plywood offcuts here. This is 6mm plywood. It is pretty solid. I think you can make some good functional parts from 6mm plywood. And thankfully, because we've got the 22 watt laser power, we can cut through this relatively quickly. I'm not going to be waiting hours for this to be cut out, which is really what I want. I want to be able to crack out prototypes and functional parts quickly. Now there are a few ways that you can obviously create the files for laser cutting. There are free tools like I think Inkscape. If you've got Illustrator, for instance, Corel Draw, you can obviously sketch out your designs like that. I'm used to using Fusion 360, so we're going to do this in Fusion 360. We're going to design it as a 3D model, and then we will export the 2D sketches that we can bring into Lightburn to laser cut. So let's head into Fusion 360 and I'm going to show you how I designed and exported this file. This Christmas, bring your electronic dreams to life with PCBWay. PCBWay specializes in higher quality PCB fabrication and assembly, ensuring your projects are a success. From prototype to production, they provide expert support at every step. Enjoy exclusive Christmas discounts on all of their services with up to 50% savings for a limited amount of time. Be sure to head over to PCBWay to grab their first come, first served coupons before you miss them. Links are in the description, and thanks to PCBWay for sponsoring this video. What we'll do first of all is we will draw in the hub itself, so we've got the reference geometry to build the rest of the bracket from. Let's go ahead and we will create a new component and we'll just call this the hub. We'll go ahead and create a new sketch, and I've got the measurements here, so it's 240 by 50 by 200 mil. So we'll just draw in a center point rectangle, and this is going to be 240 by 50, and then we'll just press E to bring up the extrude command. We'll select the sketch and we'll just extrude this by 200. Okay, there we go. So that is the reference hub, and we can bring up the appearance panel by pressing A on the keyboard. And we'll just make this a black plastic. I like to kind of like color the things that they are when I'm designing it, because when you are creating a complex part, you can quickly lose what things are, like reference models and what things you're actually going to be printing or making. I find that trying to keep the appearance as lifelike as possible is going to help you once it does become a more complicated design. That's the hub created. We'll go ahead and we'll come into the main component, we'll activate it, we'll right click, and then we will create a new component, and this is going to be the plywood bracket. Let's go ahead and we'll create a sketch and we'll draw in the actual hanging bracket parts now. So we'll select this front face of the hub and we'll bring up the project command by pressing P on the keyboard, and we'll just project the hub geometry here. So now we've got the reference. Now I want a little bit of clearance when I'm pushing this hub in and out of the bracket. You could make it really tight so it's very snug in there. I don't really need it to be, so I'm going to bring up the offset command by pressing O on the keyboard, and we'll select this sketch here, and I'm going to offset it by 5mm. I think that's going to be more than enough clearance to get the hub in and out of the bracket. Next, we'll offset it again, pressing the O on the keyboard, and this is going to be essentially the thickness of the bracket. I'm going to make this 20mm thick, but obviously because we've just offset it by 5mm, it's actually going to be plus the 5mm clearance. It's going to be 25, but if you do actually measure the distance here to here, it is actually 20mm. I do wish that Fusion 360 you could offset from the offset sketch that you've just done, but you have to always offset from the original geometry. So because we're going to be obviously laser cutting this, you are going to be dealing with a 2D design essentially. So in order to make things connect with each other, you have little recessed grooves that things can kind of slot into one another. That's what we're going to draw in now. I will select a center rectangle and we'll just select the center point here. This will be fine. Now we want the height of the recess to be the thickness of the plywood. So that will be 6. Now you can give yourself a little bit of an offset here. You could make it like 6.1mm. So then the 6mm plywood will maybe slide in a little bit easier. I found that just keeping it to the thickness of the plywood and then I just file it down so I get a really nice snug fit. But it's up to you. And then obviously this will be 20mm. We'll go ahead and draw in the other little recess parts here. So again, this is going to be 6 and 20. And we'll just put 1 down at the bottom as well, just so it's got a little bit of stability at the bottom. That's going to be 6 and 20. Okay, so now the top part. Now I'm going to be 3D printing a bracket that is going to screw into the underside of the desk, and then this plywood part is just going to bolt onto that bracket and hang down from it. So I'm going to draw in that section where it's going to have a hole for an M6 bolt so it can connect into that 3D printed bracket. And this is, again, it's just going to be a very simple design here. I don't really need to do too much. I mean, to be honest with you, I could probably just draw in 2 little holes here and that would really be enough. But just in case there's not enough material either side here and here, because this is obviously going to be gone. It's just going to be a U-shaped bracket. I just want to give myself a little bit more material just in case it does snap. So let's just draw in just 2 little wings here so we can come out. We'll come out down to the depth of the actual router, and I think 20mm is more than enough. And again, we'll just come down to this here. 20mm, and then what we can do as well is we can just add just a little bit of an angle as well, and then we'll draw in our circles as well. So we'll just come into this middle section here. So now I will draw in a 7mm circle. It's a center point circle here and here. We'll just bring this out to 7, and now you can see that I've got a lot more material around this hole here for this M6 bolt. And lastly, all we need to do is just close off this to create the U shape of the bracket, and we'll just select this point here to here and here to here. You can see it's a very, very simple design. Little things you can do is you could just have maybe some fillets here on the corners to make it a little bit more rounder. But what we'll do is we'll just press E on the keyboard to bring up the extrude command, and we'll just extrude all the parts that we need. And you'll start to see what this is going to look like. Now we want to extrude it by 6mm. This is going to be the thickness. And to be honest with you, this doesn't really matter. You know, when you're dealing with Lightburn, you are just dealing with a 2D sketch. It doesn't really care about the thickness. But as we are 3D modeling this, we might as well just make it as accurate as possible. So now I'm going to duplicate this bracket that we've just made, and I'm just going to move them into place, because you can see that obviously this one is set here, so the bracket would actually fall out of it. I mean, we do have the bottom brace here, but you kind of get the idea. So what we do is we will right click, we'll bring up the move command, and we'll just move this in a little bit. Again, you can make this however you want. I'm just kind of making this up as I go, to be honest with you. So we'll move this in by 40mm, which is fine. This time we'll do the same thing. We will open up the body here, we'll right click and we'll move it, and this time we will create a copy, and then again we'll move this. Yeah, I'm just kind of making this up. We'll just move it to what, 125. I think that looks about right. I mean, you could get it perfect so you've got the perfect amount of space either side, but I think that looks pretty good. So now that we have the 2 vertical hanging brackets, we can now draw in the cross section, the brace that is going to support these brackets here. So let's go ahead and create a new sketch, and what we'll do is we'll just base it off of this plane here. We want to capture the position. So let's go ahead and project some geometry, because this is going to help us to draw it. So we'll press P on the keyboard to bring up the project, and we want to project this, and we'll also project this, and also the hub itself. Press OK. So now we've got all of this projected geometry. What we can do is we can now select a 2-point rectangle, and we just want this to wrap around here. So we'll select from here, and we'll come all the way to this one up until here. And now we will press D to bring up the dimensions. And this is going to be 200, but we want it to, because we've got a little bit of a wrap around here, this is just going to be like this basically, just so when I push in the hub, it's not just going to kind of like fall out the other end, it's going to hit against this. So that's what we want. We'll just select 205. You can see it's actually moved it this side, which we don't want. So I'll make it collinear. We select the constraint here. I want this to be collinear with that. And now it's pushed it out this end here that you can see. We can draw in the rest of the geometry here. So we want this to be, this is going to be 20 mil, and let's make it 35. And that should be enough. You can kind of see what this is going to look like. We'll bring up E for the extrude command, and let's just select all of the geometry. So this will be extruded here. We'll extrude it by 6 mil because that is the thickness. We do not want to join it. We want to create a new body. That's very important. So let's now go ahead and we want to export these sketches. Now, I was actually quite surprised that Fusion 360 does not have inbuilt export models to SVG, which is a little bit annoying. Now, there are some plugins that actually look very, very helpful. They are paid plugins, but basically they allow you to just design your model, and then with a press of a button, it will take all of those models, it will lay them out flat, and it will also optimize to make sure that you're not wasting any material when you're laser cutting. It will optimize it onto the sheet of material that you have, and then it will export it as an SVG that you can then bring into Lightburn. So there are tools that will help you to do those type of things, but there is another way, and it's free. So you can export sketches as DXF format, which Lightburn thankfully can read. Now, you do not want to just export the sketches that you've created, because as you can see, the sketch here, it's got all of these lines. Now, we could come back into this sketch and I could trim up, I could trim up the sketch to make sure that it's exactly how I want it. But we don't need to do that. There is another way that will just make it much more simple and cleaner. Is you just create a new sketch from these bodies that you've created. So if you create a sketch, make sure that we are in the right component. We'll create a sketch and we'll click here, and you can see that this has created sketch number 3. And if we just remove these, you can see that the sketch is exactly as we want and it's all cleaned up. So now what we can do is we can save as a DXF file, and I'll just name it as bracket plywood 6 mil. We'll save it to, I do not want to save the project in the cloud, I just want to save it to my local computer. So we'll just save this here, and then you do the same thing for the cross brace that you've done here. So you bring up this body, and if we just come out of this sketch, we will create a new sketch. Click on this and you can see this has created a new sketch for us, sketch number 4. We can go ahead and we can save that as a DXF file. Now that we've got those exported, let's go into Lightburn and I will show you what to do next. So here is the DXF file of the original sketches that we created. So you can see it's brought in all of the sketch geometry, which is not what we want. If I now bring in the one that was cleaned up, I will show you the difference to it. So here you go. So you can see this is exactly what we want. So we can delete this one. We do not need this. Okay, so this is cleaned up, and just make sure that you can see if I move this, it's not moving these holes. So just make sure that you are grouping it. So then when you move it, it does keep all of the sketch geometry in place. So, we don't need to design all of the parts in Fusion 360 because these parts are the same. So I can just duplicate these and there we go. What I would do is, I would probably rotate it like this and I would fit it in here. And then if we bring in our next part here, and again, we can just duplicate it, move it across. So now that you've got your design all laid out, you are ready to obviously start cutting it on your laser engraver. I've got the Algolaser 22 watt here, so I'm setting mine to a pretty high speed of 1600 millimeters per minute. And what I do is I just do lots of passes. I've found that keeping the speed high and the passes high will result in much less charring, which I like because it just means there's less cleanup involved. So I'm running this at full power. The Algolaser has done a really good job. I haven't had any issues with it since I did first review it. You can check out the video review up in the top corner for this laser engraver if you are interested. Now this is birch plywood. This is not laser ply, which is a little bit easier to cut. You can see that it hasn't actually cut through all of the parts here, and this is just the nature of plywood because of the layers. You know, some layers are different parts of the wood. If you've got a knot in it, for instance, it's going to be much more difficult for the laser engraver to cut through it. I had to cut out some of the parts with a Stanley knife. There was just a tiny bit of material left that the laser engraver didn't cut through, and you can see here is how you put it together. I'm just filing the slots there just to get a very nice snug fit. Once it's all put together, it looks quite nice. I'm also just going to add a little bit of wood glue to these slots just to hold everything securely in place. And you can see here is the brackets. I've just made a quick design for this. I'll put the files up on Thingiverse so you can check them out if you are interested. Here it is being mounted to the underside of my partner's desk. This is the desk next to my desk. And there you go. It's a very, very simple build. I was very happy with how this come out. And I think that you can do a lot with 6mm plywood. I was pleasantly surprised how sturdy and solid this wood feels. So thank you for watching. As I said, if you're interested in checking out the Algolaser, I'll put links below, and I've also got a video review of this machine as well. That is it for today. I will catch you all later.